Okay, so in this video, we will see how this subtraction is done using R's complement method. So the R's complement subtraction we have always seen for binary number system. That is, in binary number system, the base is 2, so it is 2's complement method. So in other number systems, how this R's complement subtraction is done. So using this formula, it is R raised to n minus n. Okay, so here we are concentrating only the number of digits in the whole number part, even though the number contains a fractional part. We will be taking only the whole number part digits. That is why the formula is R raised to small letter n minus n, where small letter n represents a number of digits in the whole number part, and capital letter N represents your actual number whose R's complement needs to be found out. Okay, so what is this rule for finding out the R's complement subtraction? We have seen that in 2's complement, what we are doing is that we'll be taking the 2's complement of the subtrahend, and then that will be added with the minuend. If a carry is generated, it means that the result is positive, and we will be discarding that carry. The result will be in true format. But if no carry is generated, the result is negative, and we have to take the 2's complement of the result because to get the actual result and put a negative sign. Same when we generalize, this is the rules. That is, you have to find out the R's complement of the subtrahend. Then you have to add the complement number with the minuend. If a carry is generated, you have to discard that carry and the result is positive and in its true form. And if no carry is generated, then the result is negative and will be in R's complement format. So in order to get the true format, you have to take the R's complement of the result and then put a negative sign. Okay. Now, as told you, in 2's complement, we know that it was just not only in binary number system, the 2's complement is nothing but 1's complement plus 1. Okay, in every number system, that is correct. That is, in order to find out the 2's complement, you just take the 1's complement and add 1 to it. You will get the 2's complement. And for binary number system, you know the shortcut method for that, isn't it? You just scan from the LSB until you obtain a positive 1 value, not positive 1 value. And from the remaining digits, you will be inverting. Okay, but in the case of other number systems, it is not possible of inversion. So instead of applying R raised to n minus en rule, we know that the shortcut method for finding out the R minus 1 complement, isn't it? What is R minus 1? That is 9's complement for decimal number system. It is subtracting each digit from the highest possible number, that is 99.999 minus 36.252. In this case, it is if you want to find 9's complement of 36.252, it is 99.999 minus 36.252. And what if you want to find out the 2's complement, 10's complement? The R's complement in base 10 is 10's complement. So what if you want to find out the 10's complement, you found out 9's complement here, just add 1 to it. And where this 1 will be added, this 1 will be added to the LSB, that is 99.999 minus 36.252 is 63.747. That is your 9's complement. Then 1 is added here, so it's 63.748 will be your 10's complement. Okay, similarly, if you want to find the 8's complement of 237.614, what you have to do, you have to find out the 7's complement and then put a plus 1. So how will you find out 7's complement of this number? It is 777.777 minus 237.614, that is 540.163, which will be added with 1. So it will be 540.164. Okay. Similarly, finding out 16's complement of 4AC.29, you know that 15's complement is FFF.FF minus 4AC.29. That is B53.D6. That has to be added with 1. So result will be B53.D7. That is the 16's complement of 4AC.29. Okay. Similarly, finding out 2's complement of 01011.11, you are subtracting this to find out the 1's complement, plus 1 will give you 2's complement. Or again, there is one more shortcut method for 2's complement. You are just scanning from the LSB. So LSB is 1, you encounter the first one. from there, from the next bit onwards, you are inverting. So this becomes 0, 0, 0, 1, 0, 1, isn't it? And what about five? You're finding out the not five, six complement, because your base is six. So sixth complement of 132.45 is you're finding out the fives complement, and then that has to be added with one. So it is 423.1 plus one. So it is 423.2. Okay, so this is how you will find out the r's complement of a particular number. You already know the r minus 1's complement. You just add 1 to it. Okay, so the form you when the question is asked to find out the r's complement, just write the formula first and then go for the second last step. That is 99.99. So we will see some examples of subtraction using r's complement method. So first example is how you will perform 3.2496 minus 55.6 to the base 10 using tens complement. Okay, this is of base 10, so you can perform subtraction using tens complement. So you are making the number of digits of the two numbers same. So it is here it is two digits for the whole number part. Here it is only one digit, so I am making it as 03.2496 minus 55.6. Here it is four digits, so it is 60000. So when that step is over, you can go for finding out the tens complement of 55.6. So what is tens complement of 55.60000? It is, the formula is r raised to n minus n. So here it is, since it's a decimal number system, I wrote it as 10 raised to 2 minus 55.60000. Actually, this step is not necessary. That is what I'm trying to say. You don't need to mention every steps in detail for just finding out the tens complement of this number. You know that you know to find out the nines complement of 55.6, isn't it? How will you find out that? It is 99.9999 minus 55.6000, isn't it? So this part will give you the nines complement of the number, and that number plus 1 will give you tens complement. Okay, so what is this part? This part is, you got it as 44.3999. Now this 1 has to be added with the LSB. So it is 9 plus 1, 10 with a carry 1. It is a 10 with carry 1, 10 with carry 1, 3 plus 1 is 4. Which is equal to 44.4000. That is the tens complement of this number. Now this tens complement has to be added with this number, which will give you 47.6496. There is no carry generated from the MSB. So what it indicates, it means that this result is in tens complement format. That is 47.6496 is in tens complement. So in order to, and that this result is negative. So in order to find out the true format, you are taking the tens complement of 47.6496, which is nothing but nines complement of this number plus 1. So it is 99.9999 minus 47.6496 plus 1. So it is 52.3503 plus 1, which is minus 52.3504. Okay, so the 3.2496 minus 55.6 to the base 10 is equal to minus 52.3504. Similarly, you are finding out the subtraction of two octal numbers using 8's complement. So 23 to the base 8 minus 746 to the base 8. So it is 023 plus 8's complement of 746. So how will you find out 8's complement of 746? It is you are finding out the 7's complement of this number plus 1. How will you find out 7's complement of 746? It is 777 minus 746. Okay, 777 minus 746, and that will be added with 1. Why I didn't take why I didn't represent 746.0? It is not necessary. Why? Because in the first number there is no decimal part, there is no fractional part. It is just written as only the whole number part. But if it was 23.1, then I should have taken the 746 as 746.0. But here it is, both numbers are represented using whole number part only. So here I need to consider only the whole number part. So it is 777. Okay, 777 minus 746 plus 1. So the result is 32. This is your 8's complement, and that has to be added with your 23. So 023 plus 32, that is 055, which means that no carry generated from your MSB. So since no carry, the result is negative. So take the 8's complement of the result, which is done by 777 minus 055. That is 7's complement only, plus 1 will give you 8's complement. So it is 723 minus 723 to the base 8. Similarly, I am just taking the reverse of this number, that is my subtracting from a bigger number to small number, that is 746 to the base 8 minus 23 to the base 8. So 746 plus 8's complement of 023, because 746 consists of 3 digits. So I am making 23 as 3 digits. So it is 023. So 8's complement of 023 is 777 minus 023, 754 plus 1, that is 755. Now you are adding 755 with your number 746, which will give you 6 plus 5 is 11, which is greater than your base 8. So subtracting 8 with a carry 1. 10 minus your result is 4 plus 1 5, 5 plus 5 is 10. Again the result is invalid. So subtracting 8 with a carry 1. 7 plus 7 is 14, plus 1 15. So again 15 minus 8 with a carry 1. Okay, so this carry has to be added with the LSB, isn't it? So what is 15 minus 8? 7. 10 minus 8, 2. 11 minus 8 is 3. So 7 10 to 3. Again, you have to carry. There is a carry generated, but you don't need to add this carry. Why? Because it is in 8's complement subtraction method. As per the R's complement subtraction method, when a carry is generated, it has to be discarded. Carry need not be added with the LSB. That is why first I wrote it as adding 1, then I cut it off. Okay, just mentioning it as this has to be discarded, and the result is positive. Hence, the result is plus 723. Okay, so whenever a carry is generated, that has to be discarded. If no carry is generated, you have to take the R's complement of that particular result and put a negative sign. Now, example using 16's complement. So example is AB 0.1 minus 9A3 to the base 16 using 16's complement. So how will you find out this? Here you have to make sure the number of digits in both sides, that is a whole number as fractional part, are same. So for AB, I make it as 0AB, and for since there is a fractional part here, I make it as 9A3.0. Okay, that is compulsory. Otherwise, your result will go wrong. So 0AB 0.1 plus 16's complement of 9A3.0. Okay, so how will you find out 16's complement of 9A3.0? It is F minus 9A3.0. So this part will give you your 15's complement, and that result plus 1 will give you 16's complement. So how will you find out this part? You got it as f minus 0 is f, f minus 3 is c, f minus a is 5, f minus 9 is 6. And that is your 15's complement only. Then you are adding your 1 that is done on LSB. That is your this part. So f plus 1 is 16. 16 is not there. So it's up, you have to subtract with 16 and a carry is provided. So c plus 1 is d, 65d. Okay. So this is your 16's complement. Now you're going to add the 16's complement with the OAB 0.1. So OAB 0.1 plus 65D, what happens? 1 plus 0 is 1, B plus D is 24. So 16 has to be subtracted with a carry 1. So A plus 1, that is B plus 5 is 16. Okay, then 16, again, 16 has to be subtracted with a carry 1. So 6 plus 1 is 7. So the result is 708.1. Okay, so 708.1, there is no carry generated. It means that the result is negative. So you are taking the 16's complement of this result. So what is 16's complement of 708.1? It is F minus 708.1. So which will give you 15's complement of this number plus 1. So you are finding out this part alone first. So point F minus 708.1. So F minus 1 is E. F minus 8 is 7. F minus 0, that is 15 minus 0 is again 15, that is F. F minus 7 is 8. So this is your 15's complement only. Now we are adding this 1 here. So E plus 1 F 857. So it is A minus 857 point F. So this is how you perform subtraction using your 16's complement method. Okay, so this is applicable to every number system. In order to find out the R's complement, just take the R complement of the subtraction, then add. You have to add with the minuend and do the steps. Okay, so that's it. Thank you.